Okay, Balloon Girl Jess, welcome. We are now live from Cabrillo College in Santa Cruz, California, and I'm going to go through the explanation of yesterday's awesome physics demo. What you're seeing here, ouch, that's right, is a bowling ball. It's a 12-pound bowling ball attached to the ceiling, so I have a big bowling ball pendulum. And what I did yesterday was sit at that chair, pull this bowling ball pendulum right up to my nose, let it go, and hope for the best. But in reality, I knew I was going to be completely safe because of the laws of physics. So let me just quickly give you a bird's eye view of what happened. I'm going to pull this bowling ball right up to the camera of the iPhone, let it go, and hopefully my iPhone doesn't get crushed. Oh, so close. In reality, I'm 100% completely safe because of the simple laws of physics, conservation of energy. So what I'm going to do is pull this around. I'm going to get in that seat and sit there, pull it up to my nose, and then give you another perspective. Okay, hopefully you can still see me. I can't see any comments. I'll try and talk loud, but I'm going to pull this right up to my nose, let it go. I'm going to just first make sure. I'm going to pull my iPhone back a little bit. I want to make sure that I don't pull it up too far. Okay, here we go. 12-pound bowling ball, pulling it right up to my nose, letting it go, hoping for the best. Oh, that's close. Okay, I'm going to give you another cool perspective from the side and then explain why this works. Hey there, Joe McCullough here. Welcome to my classroom at Cabrillo College. Today, we're talking a little bit about conservation of energy. Thank you for the heart. What I'm going to do is show you this demo, but give you a bird's eye view. So let's see if I can move this camera, get this all set up. Okay, I'm going to pull this up a bit, and then we'll go through a little bit about why this works. Bowling ball, right up to my nose. In fact, to make it interesting, I will close my eyes and hopefully not get smacked. You ready? Wish me luck. Oh my God, no. Okay, so why am I completely safe? It has to do with conservation of energy. So I'm going to teach you just quick little 5 minutes of physics. Let me turn this. There's three main forms of energy associated in this demonstration. First one, gravitational potential energy, and the equation for that is mgh. M is mass, g is the acceleration due to gravity, h is height. Second form of equation, or second form of energy involved, kinetic energy. Equation is 1/2 mv squared, where m is mass again. In this case, v is the speed in meters per second. And we also have heat, which is thermal energy caused by friction and air resistance. What is height measured in centimeters? So usually we measure height in meters. The height I'm pulling up that bowling ball is maybe less than 1.5 meters, 2 meters. Okay, so what's happening is, I'm going to zoom in here. Let's see if I can show you a little, whoops, hello. Sorry about that. That's what happens when you shoot live. Okay, so here is a pendulum person. What you're seeing on the screen are plots of, we've got kinetic energy, potential energy, and total energy. When I lift this up, the height is increasing, so the potential energy is increasing. And then at the very highest point, that's all the energy it's ever going to have. Once I let it go, what you're going to see is the elevation starts to decrease. So the potential energy decreases, but speed is increasing, so kinetic energy is increasing. As this person is swinging back and forth, The total amount of energy is the same. It's just constantly getting converted between potential energy and kinetic energy. Now, this is in an ideal world where there is no friction or air resistance. Let's see if I can. Okay, so what happens is, let me pull this over here again one more time. Zoom in. So once I lift this bowling ball up to my nose, it has all the energy it's going to have at the top. As long as I don't push it and give it some of my energy, then I'm completely safe because the bowling ball cannot swing to a higher height than it started from if I don't give it some kind of initial push. However, I'm completely safe because of air resistance and friction. It can never swing even to the same height that I released it from. Every single time it swings, what happens is air resistance and friction is converting some of the energy into heat. And eventually, the swing is going to stop altogether. When that happens, the temperature in the room will have increased slightly because all of the kinetic and potential energy that the bowling ball had is now all converted into thermal energy, heat, because of air resistance and friction. So I pull the bowling ball up to my nose. Let me turn this a little bit. Pull it up to my nose, and as long as I release it from rest and I don't give it any energy of my own, then the bowling ball cannot swing to a higher height than I released it from. So I'll just look at here, and as long as I don't move my face forward, I'm completely safe. And what you'll see is every single time this bowling ball swings, it's actually swinging to a slightly lower height. And that's because air resistance and friction in the room is taking some of the energy and converting it into heat. Well, that's kind of it for today's little physics demonstration. Are there any questions that I can answer about this physics demo? For those of you who are new, my name is Joe McCullough. I'm the physics department chair here at Cabrillo College in California, and I'm getting on Periscope every single day for an entire year and doing scopes designed to educate, entertain, and inspire. Did a couple magic tricks this week. What's going to be on board for the rest of the week is I'm going to be giving you some really awesome time management tips. School's right about to start, and it's really important for students and for everyone to be able to manage their time. If that sounds interesting to you, please swipe from left to right on an iPhone, straight up on an Android. Please follow me, share this with your friends. I'm going to be broadcasting every single day for the next year. This is day 12. That's it for today. Thank you so much for joining. Again, my name is Joe, and I look forward to touching base with you in the near future.